Let's suppose you wanted to integrate this particular integral here, 1 plus e to the x over 1 minus e to the x. You go through your strategies. What do we have? We don't have a rational expression for the integrand, so we don't expect partial fractions, not the way it's written here. Integration by parts depends what you can do with it. Trig integral, we don't have any trig functions. Trig substitution, we don't have the square root type of problem that we need. Not saying you couldn't do it, you might have to be creative. Well, anyway, if you can't select one method to begin with, or one of the ones I mentioned, I always like to start with a U-substitution and see where I get from there. And keep in mind that sometimes you can start off with a regular U-substitution, and that doesn't do it for you as far as completing the problem. You might have to go to another substitution. So it just depends on the complexity of the problem. So for this one here, I'm going to start one substitution and let you finish it here. So I could let u equal to e to the x, or I could let u equal to 1 minus e to the x, or 1 plus e to the x. Several ways we could start, but let me do it this way first. U equal e to the x, and then I'm just going to say the natural log. Take the natural log of both sides here, and notice here that I'm letting u equal to e to the x. E to the x is a positive number because e is a positive number. So any positive number to any kind of power, negative or positive, will be a positive number. So I don't need absolute values here. But on the right side, I take the natural log of e to the x. Of course, that's x. So if I go dx, then equal to, derivative of ln of u will be 1 over u, and then chain rule will give me a du here. We got this. So then this is going to equal to the integral of 1 plus, and then e to the x is u. So I get 1 plus u. And the denominator, I get 1 minus e to the x. E to the x is u. And then the dx here can be replaced by du over u. So this will be du over u. And then I got the u under here, so I just multiply with this. Now, from here, you have it set up, but we have it set up as a rational expression. So we could use partial fractions from here. So you would take this out to the side, 1 plus u over 1 minus u times u. And then I use the partial fraction decomposition procedure. This would be a over one of these, doesn't matter. I'll put it over u plus the linear factors here. So that it's a constant, not an ax or b, ax plus b, whatever. And then the next one would be b over 1 minus u. And then you would go through the procedure for partial fractions and find the value of a, find the value of b. So the value of a comes out to be 1. I'll give you that. The value of b comes out to be 2. So you got integral then. This would go over here. And this would be the integral of 1 over u plus the integral of 2 over 1 minus u. And those will be natural logs. I'll let you finish that. I'm going to do it another way. It's still a U-substitution, but it should be the same answer. If you simplify yours, it should give you the same answer as mine. So just in case you're not sure whether your answer is correct, you can check it with the second method I'm going to use. But this is the way you would set it up. And then a would equal to 2, b would equal to 2. And these will be, when you integrate them, will be natural log of u. And then this one would be minus, because of this minus u here, minus 2 natural log of 1 minus u. And these would have absolute values because we have minus here and this one here. Do it another way here, but that way will work. So here's what I'm going to do for this one. I'm going to do it this way. Got the integral, then I'm going to rewrite this. So it's 1 plus the integral of 1 plus e to the x, and then over 1 minus e to the x. So I'm going to use a technique I've used in other videos where I simply multiply by 1, add 0, just to rewrite the integrand. So here what I'm going to do is this. Let me do this here. I'm going to add minus e to the x to the numerator and subtract e to the x. All I'm doing is adding an e to the x right here and then subtracting an e to the x. and then I already had an e to the x. So that's the same thing, okay? Got a 1 minus e to the x plus e to the x gives me 0. So I'm still left with 1 plus e to the x. So I haven't changed the integral. This is dx over here. Now let's do this. Now I separate these into two integrals. So this will be 1 minus e to the x over 1 minus e to the x, be dx here, plus, what do I have left up here? I have an e to the x and an e to the x, so this will be the integral of 2 e to the x over 1 minus e to the x. This is dx. Now, the other substitution could work, 1 minus e to the x equal to u, and then take it from there. Maybe you still have to do partial fractions. I didn't try that one, but this is what we have here. All I did was again added and subtracted an e to the x right here. That's just 0, so it hasn't changed it. And then I broke it down into two integrals, and now this right here, then this is just the integral of 1 minus e to the x over 1 minus e to the x. That's just the 1 e to the x. And this one we don't really need a U-substitution, but just to make sure you see what we're doing here, I'm going to let u equal in this one here to 1 minus e to the x. This one's going to be easy to integrate. The integral of 1 dx is just x. So this integral is just going to be x here. This is going to be equal to x. That's done for that one. And then for this one here, du would equal to, the derivative of 1 is 0. The derivative of minus e to the x is minus e to the x. And normally we take the derivative of the exponent just in case it's like an x squared or a 2x because of the chain rule. But derivative of x is 1, so it doesn't change. So then this is equal to, and this is a dx here. So I'm going to multiply both sides by a negative here. So I get e to the x dx, and this will be a minus du. And then we go back to this integral here then. So this will be plus, and now let's make the substitution here. So I'm going to have the integral of, now I'm working with this integral here. In the denominator I have 1 minus e to the x, but I'm using that for my u, so I just put a u here. And then e to the x dx from right here, this is minus du. I just put the minus out here, minus du. And still have this 2 here. So I could actually put a minus, put the 2 here also, be minus 2. And then I go up here, equals 2. So this is going to equal to, I got the x there, and then I had the minus 2, and then the integral of du over u, or you can say 1 over u du, is the natural log of u. And this could be negative, so we'll use absolute values of 1 minus e to the x plus the constant of integration. And this should give you the same answer that I set up for you in the first part, doing it the other method. If you go ahead and simplify that, complete the partial fraction and integrate and simplify what you got, you should get this answer right here. So those are two answers, two ways to work the problem. And there could be other methods, might be a little bit longer. Like I said, letting this u equal to 1 minus e to the x could be another option. You can try that and see if it works. But for right now, this is the solution right here. Doing it this way, like I said, the other way should give you the same thing. Thanks for watching. We'll see you next time.